Imagine you're at a track meet. The runners line up, the starter pistol fires, they're off. But what does it really mean to be in motion? That's what we're going to explore in this exciting journey into the world of motion. Get ready to discover the science behind how things move. Fasten your seatbelts, and let's begin. We encounter motion in our daily lives, from a ball soaring through the air to a car speeding down the highway. Understanding how things move is key to understanding our world. Motion is simply a change in position over time. When something changes its location compared to a fixed point, we say it's in motion. Think of a game of tag. If you're running from the person who's it, you're definitely in motion. But what about when you're standing still, catching your breath? That's when you're at rest. Rest means something is not changing its position, it's staying put. So motion is about movement, and rest is about stillness. Motion isn't always straightforward. Sometimes it's a straight line, sometimes it's a curveball, and sometimes it's a repetitive dance. Let's explore the different types of motion. First up, rectilinear motion. Imagine a car driving on a straight road. That's rectilinear motion, movement in a straight line. Next, we have circular motion. Think of a Ferris wheel rotating gracefully. That's circular motion, movement along a circular path. Finally, there's periodic motion, which is movement that repeats itself in a regular cycle. The pendulum of a grandfather clock swinging back and forth is a great example. Now that we know about types of motion, let's talk about distance and displacement. These two terms are often used interchangeably, but they have distinct meanings. Distance is the total path traveled by an object. So if you walk 10 meters forward and then 5 meters backward, the total distance you covered is 15 meters. Displacement, on the other hand, is the shortest distance between the starting and ending points. In the previous example, your displacement is only 5 meters because you ended up 5 meters ahead of your starting point. Section 5. Speed, velocity, and acceleration. The need for speed. Let's talk speed. Speed tells us how fast an object is moving. It's calculated by dividing the distance traveled by the time taken. For instance, if a car travels 100 kilometers in 2 hours, its speed is 50 kilometers per hour. But speed doesn't tell us the direction of motion. That's where velocity comes in. Velocity is speed with a direction. So if a car is traveling north at 50 kilometers per hour, its velocity is 50 kilometers per hour, north. What about acceleration? Acceleration measures how fast the velocity of an object is changing. When you press the gas pedal in a car, the car accelerates. Its velocity increases. Section 6. Uniform and non-uniform motion, a change of pace. Now let's delve into uniform and non-uniform motion. Uniform motion means an object is moving at a constant speed in a straight line. Think of a train traveling at a steady 100 kilometers per hour on a straight track. Non-uniform motion, as you might have guessed, is when an object doesn't move at a constant speed or direction. A car navigating a winding road is a good example. Understanding these types of motion helps us analyze how objects move in different situations. Section 7. Graphing motion, a visual journey. Graphs are incredibly useful tools for visualizing motion. Distance time graphs and velocity time graphs provide valuable insights into how objects move. A distance time graph plots the distance traveled by an object over time. A straight line on a distance time graph indicates uniform motion, while a curved line represents non-uniform motion. A velocity time graph, on the other hand, plots the velocity of an object over time. A horizontal line on a velocity time graph signifies constant velocity, while a sloped line indicates acceleration. Section 8. Motion in our world. Motion is everywhere. From the planets orbiting the sun to the blood flowing through our veins, the universe is alive with movement. Understanding motion allows us to explain natural phenomena, design incredible machines, and explore the vast expanse of space. Think about the sports you love, the music you enjoy, or even the simple act of walking. Motion is at the heart of it all. As you learn more about motion, you'll start to see the world in a whole new light. You'll be able to appreciate the physics behind everyday occurrences and marvel at the wonders of the natural world. Section 9. Keep exploring. So, there you have it, a whirlwind tour of motion. We've covered the basics of motion, explored different types of motion, dived into concepts like speed and acceleration, and even learned about graphs. Now it's your turn. Look around you and identify objects in motion. Can you tell what kind of motion they're exhibiting? Can you estimate their speed? The more you observe and question, the deeper your understanding of motion will become. Keep exploring, keep questioning, and never stop learning. Stop.